We are going to continue our forecasting electricity consumption using time series model. Okay, we're focused on, today is a simple moving average. Okay, time series, as you know, is a collection of equally spaced temporal data. Okay, time series can consist some or all of the components such as trend, which is a long-term pattern, cyclical patterns, mean a repeated up and down movement. Seasonal is actually regular fluctuation during the same month or quarter, and irregular unexplained random component. I think this one we skip. Okay, we are going to this video we're going to focus on the simple moving average, where let's say for example if I use m equal to 3, mean I'm going to use the previous 3 months to forecast the fourth month result, and so on. Okay, and then we focus on the simple moving average. Okay, first. So with this, we move to our data. We have the monthly UTHM electricity consumption from January 2009 until December 2020. Okay. Then we're going to use a moving average 3, MA3. So mean I'm going to use the previous 3 months to forecast the month number 4. Month number 4. So it's very easy. AVE average of the previous 3 months. Then we get month number 4. Then you can copy it down the result. Okay. Then again, you have the real data, predicted data. Then you can do the error analysis. Okay, first one is a absolute error. Second column is a squared error, which is your absolute error power 2. Then relative error, which is your AE divided by the real data Y. Okay, since we forecast start from month 4, the error can be conducted start from month 4. So absolute error is a ABS, absolute value of the difference between real and forecasted or the predicted. So we take ABS so that the difference you won't get negative value. Okay, squared error is actually your absolute error, your power 2. Relative error is actually your absolute error you divide by the real data. Okay, then I can select out all the data. Okay, and then I can find MAE, MSE, MAPE. MAE is a mean absolute error. So you take average, average of your absolute error, then you get MAE, mean. In Excel, they call as a average functions. So, and then you copy it. So this will be the average. Hold on, wrong. Should be here. Then you copy it. So MSE is bigger because squared error, you squared it. Okay, MAPE, you have to, the average of your relative error you time 100%, so become mean absolute percentage error. So, the moving average will get 14.17% errors. Then we can plot, let's say, the graph to see how well the moving average 3 suit the real data. So select all the data and then insert menu, scatter here. So it's not plotted correctly. Then select the graph, select data, you remove everything. Later it add the series name. First we want the actual data, so the series name, click the actual series x value, clicks value. I just want to show years and month, so 2009 Okay, month, okay, include here the y value. So the actual y value. Okay, later on you add in one more series. Now select the MA3. The x value, it's the same thing, the values. The y value. So select. Okay. Okay. So we want to see the x-axis, the month and year. So if that's okay, change the chart type to line. This one. Okay, right click, format the grid lines. No lines. Okay, you can change the color. The blue now is the real data. Change to the darker blue. Width, I change it to 2 point. Okay, the orange color is actually the okay MA3. I want to select MA3. I want to change to red color. The width, I change it to 2 point. So you can see scale MA3. I use the previous 3 months to predict the previous 3 months to predict month 4. And then you can see that how well I can do the future forecast. Month 1. This is a real data. This is a predicted. Okay, I can only forecast 1 month ahead, 1 month ahead, because MA3 I use the previous 3 months. So January 2021, I will use October, November, December 2020. So you can forecast only 1 month ahead. Okay, like this. Okay, so you see your data, that red color. I want it to show. Okay, include this one. Okay, compared to our just now we do, this is a multiple linear regression. Even though you got that cyclic pattern, but it still follow the linear trend. So the errors, this is about what's the error just now, 29% something, 29. Okay, and then the moving, okay, moving average, okay, MA3, use the previous 3 data, simple moving average 3, we get okay the pattern, but the error is okay reduced, but still not that very well overlap. If possible, red color here near to the blue exactly overlaps. Okay, with that, okay, that's why we got another one which is called weighted moving average. Okay, weighted moving average. Okay, so with this, I'm going to duplicate, move or copy, create a copy. Okay, this is a weighted moving average. Sheet 1 just now is okay, the simple this one time 100%. This is simple moving average. Okay, so I think the W1, the weightage, okay, W1, W2, W3. Okay, for weighted moving average, okay, let's say M equal to 3. So you got W1 times man1 plus W2 times man2 plus W3 times man3. Okay, if we use the simple moving average, because we divide by 3, so mean W1 is actually 1/3, W2 is actually 1/3, W3 is actually 1/3. So initially, I will put, let's say this is equal to 1 divided 3, or 1/3. Okay, then we want the total weight, total must be equal to, the total, you put the constraint, the total must be equal to 1. Total W1, W2, W3 must be equal to 1. So this is a, let's say, weighted moving average tree. Then I have, change the formula will be equal to, W1 multiply man1 plus W2 multiply man2 plus W3 multiply man3. W are constant. So that when you copy it to the next man, it maintains the same rows there. W JKL J2 K2 L2. So that when I copy it, you see here, but I move to man, W1 times man2, W2 times man3, W3 times man4. So I can copy it down. Initially you see there's no difference, because if I put W1, W2, W3, 1/3 will be equal to the simple moving average tree. Now I'm going to vary the coefficient for W1, W2, W3, so that the error, the MAE, will be minimum. I'm going to minimize this MAE by vary the value for W1, W2, W3. With this I'm going to use the data menu, the solver. If you don't have the solver, then you go to file, more, options, add-ins, go, check on solver add-in. Once you click OK, it will be in the data menu, solver. I'm going to set the objective. I want the MAE, or I want to set MSE. MAPE also can. There's no rules that I want to set MAE to a minimum value of 0 by changing variable cell. I want by vary W1, W2, W3, and then I want the constraint is the total must be equal to 1. Then I add, cancel. So you see. So set objective, this is my MAE to a minimum value of 0 by varied say W1, 2, 3, and then the constraint is the total of W1 plus W2 plus W3 must be equal to 1. And then I solve. And then OK. So once OK, you see initially W1, 2, 3 are all are 1/3 now. You see W1 has a smallest weightage 0.10, W2 0.11, W3 0.78. And then the errors, initially simple moving average, the error is 14.17. Now the weighted moving average, the error reduced, the MAP reduced to 7%, 12%. And the gaps of the red color and blue color is closer compared just now, quite far. Far now is closer. But I cannot answer why each time we run the coefficient W1, W2, W3 are varied. Let me see. My time series model weighted different. Each time you run, okay, W1, W2, W3, okay, slightly different. But the errors 12.01, 12.04, this one a bit bigger. Because each time we run, this value is different. Okay, so this with this we includes actually two model, simple moving average and the weighted moving average. These two model. Okay, so with where the simple moving average is okay, very easy. If I take case simple moving average 3, then I average the previous 3 historical data to get month number 4 data. So with this, okay, your W1, W2, W3 is actually 1/3 because average mean you have, okay, you add up these 3 divide by 3. So their W1, W2, W3 are equal to 1. If weighted moving average, initially I put all are 1/3, so equivalent to a simple moving average. Later on, I'm going to vary this W1, W2, W3 by minimizing the MAE. You can try, let's say we minimize MAPE. Then using the solver. Okay, I set my objective. This is my MAE to a minimum value of 0 by changing variable. This will be my W1, 2, 3. The constraint is the total must be equal to 1, and I use a non-linear models, and then I solve it. Okay, then we can see that simple moving average 14% and the graph, the real and the simple moving average 3, even though it follow the patterns, is still not that exactly overlap. Simple moving average, we see here a more closer, but still got errors about 12%. So with this, thank you for your attention.